Hey, so before we get into lesson 1.2, I want to talk about moving the decimal. And we're not even going to talk about moving the numbers, we're going to move a decimal. So anytime we multiply, anytime we multiply by 10, we are increasing the number's value. Okay? Anytime we multiply by 10, we are increasing the number's value. So that means that this decimal is going to be moving over to the right. Okay? So if we're multiplying by 10, we're moving the decimal over to the right. Okay? So the opposite is in play if we decrease. If we decrease by 10 or divide by 10, or it may say multiply by 1/10, we are making the number smaller. Sorry, I got choked. So that means that the decimal is going to be moving to the left. So when we increase by 10, the decimal moves to the right. When we decrease by 10, it moves to the left. So if this theory is true, let's try it out. I promise you I'm just coughing because of allergies. Okay, so let's do 1 and 234 thousandths. Okay? My little... Excuse me 1 second. I'm sorry, I started coughing again. So I'm going to rewrite the number sideways to see. So I have my little thing here, my buckeye, right there. Now my buckeye is my decimal point. So if I have 1 and 234 thousandths, and I'm going to multiply it times 10. And remember what we said. When we multiply, this decimal is going to move to the right. And you're saying, well, how do I know how many times? Well, I said multiply by 10, and there's only 1 0, so 1 time. So you can say 1 and 234 thousandths times 10 is equal to 12 and 34 hundredths. So let's take this a little step further. Let's say we have 12 and 34 hundredths times 100. Okay, we're multiplying, and we're happen to be multiplying by a whole number. Okay? Now, how many times do I need to move the decimal? Well, I'm going to look right here. I have 2 zeros, so 1, 2. Or I have some people say 10, 100. So 12 and 34 hundredths times 100 is 1,234. Now, let's try the decimal. Dividing. Let's put it right here. So when we divide, the numbers are going to get smaller. So they're going to move to the left. Think of a pizza. If you have a pizza by yourself, you're going to have 8 slices. But if you have to share with your siblings, you're going to get less and less each sibling you have. So if I have 123 and 4/10 divided by 10, that means my little... I just want to blank what this was. My little decimal here is going to move 1 time to the left. Okay? So 123 and 4/10 divided by 10 is equal to 12 and 34 hundredths. So you can see that 123 and 4/10 is greater than 12 and 34 hundredths. That's just common math. We know that if we just put this in money, I'd much rather have $123 than $12. Okay? So what if I have 12 and 34 hundredths divided by another 10? Well, I would move it one more place to the left and get 1 and 234 thousandths. So that is how you move the decimal over. Okay? for each 10 when you multiply each 10. Whether it's times 10, times 100, times 1,000, you're going to move that decimal to the right for every number of zeros. Now, this only works for when you're doing 10, okay? You can't do any other number. This is only 10. Then when you divide, you are going to be messing with moving the decimal to the left. All right, that was a quick little intro to what we're going to be working with today. And it has disappeared, and it's magically reappearing right now. All right, so what we're going to be doing is we are going to explore patterns. Okay? Now, we're going to be looking at these models. Okay, I want you to look at these models very carefully. I have model A, model B, model C. Okay, here's what I want you to do. I want you to look at each model, and I want you to write the decimal for each, write the decimal value, what it represents for each one of these. You should be able to do this in about 60 seconds. So, I'm actually going to give you 60 seconds. So let's go. All right, you should be through with A. We'll start it on B. Okay? Got about 15 more seconds. Ten more seconds. All right, let's look at it. Letter A. All right. So we have a flat. Now remember, a flat is equal to 100. Okay? So out of 100, how many of these are shaded in? That's right, 3. So you have 3 out of 100. Okay? 3 out of 100 is the same thing as saying 3 hundredths. Now, let's go to the next one. You have rods that are colored. Just count the rods because each one of them means 10. So 10, 20, 30. So we could either say 30 out of 100 is colored in, or 3 out of 10. Whichever one you want to do. So that equals 3 tenths, or we could put 30 hundredths. Okay, letter C. All of them are colored in. So that means it's going to be a whole number of 3. Okay, so we've labeled that one. Okay, the shaded region in Model B is how many times the shaded region in Model A? Well, Model B is 3 tenths. Model A is 3 hundredths. Okay, so the question is, how many times greater is the 3 tenths than 3 hundredths? Think about it. How many times am I going to have to move this 3 to get to the tenths? 1 time. And that 1 represents 10. So it is 10 times greater. Okay? I'm so sorry about the cough. The shaded region in Model C, which is 3.0, compared to model B. Okay? How much is it? That's right, 10 times. All right, now let's look at this model, right? The equations down here, and remember what I said. If you're multiplying, the decimal moves to the right. If you are dividing, moves to the left. Okay, let's look right here. I have 3 hundredths times 10. So I'm going to take that decimal, move it over one time, and I get 3 tenths. 3 tenths divided by 10. Move that decimal one place. On number 3. Okay, right here, I'm dividing by 10. So that means this decimal is going to move to the left. So I have 3 tenths turns into 3 hundredths. And I have the number 3 divided by 10. Move that decimal to the left. And that turns into 3 tenths. Okay, let's fill in the pattern here. Right down here, try these. This pattern is multiplying, so that means each time we go, the decimal is moving to the right. Okay? So 3 thousandths times 10 is 3 hundredths. See, we just moved that decimal over. 3 hundredths times 10 is 3 tenths. Now, if we continue this pattern, this blank is going to be the number 3. And 3 times 10 is 30. Now, this is going to be a little different because we're dividing. That means the decimal is going to move to the left. Okay? And with whole numbers, the decimal is at the very end of it. So 500 divided by 10, move that decimal, you get 50. 50 divided by 10, move that decimal, you get 5. 5 divided by 10, you get 5 tenths. 5 tenths divided by 10 is 5 hundredths. 5 hundredths divided by 10 is 5 thousandths. Okay, let's look at the next page. Look at the model in problem 2. Problem 2. Okay, that's this one. And label, and the labels you wrote. Now shade some or all the grids in the model below to show 30 hundredths. 30 hundredths. 30 hundredths. So 30 hundredths, okay? 30 hundredths. That's going to be a little, we got to think about that, okay? Because we have 30 hundredths. Write it out, okay? 30 hundredths is the same thing as me saying 30 over 100. Now, that means I have to color in 30 cubes out of 100. But look right here. They gave us 3 cubes. So does that mean I have to color in all 3? No, it doesn't. Because each one of these models represents 1. So this could be 1, 2, 3. And it's saying we have to color in 30 hundredths. 30 hundredths isn't even a whole number. So that means I'm going to come over here to one of these and only color in 30 of them. Or, if we think even bit more about this, 30 hundredths is the same thing as saying 3 tenths. So I'm just going to go right here. 1, 2, 3. So do you see how nice and neat I did it? I didn't go 1, okay, I'm going to skip 2, let's do this. Or I didn't go in here and go, okay, I'm going to color this one, this one, this one, this one, this one, this one. Let's make a pattern. Do nice and neat. Okay, nice and neat. Now, find the model on the previous page. Right here. Find the model on the previous page that has the same shading as the model we just did. Okay, Which one has the same shading? Okay, there it is right there. Okay, if you said B, you're right. Now, what label did we give to B? We said B was equal to 3/10 or 30 hundredths. Y'all thought I was crazy when I said 3/10 and 30 hundredths are the same thing, didn't you? Yep. Okay, number 8 says use the model you shaded in for problem 7 to write a decimal for 30 hundredths. So basically, all you have to do is rewrite number 7. The decimal for 30 hundredths is 3/10 or and 30 hundredths. Okay. How do both shaded models show that 30 hundredths is the same thing as 1/10? Now, remember a few days back, I said when we have a sheet, the sheets are made of how many rods? 10. Very good. Now, how many? So each sheet or each flat has 10 rods. Okay? So that's basically saying that when you have a column, each column is a rod, is worth 1/10 of the sheet. So we could say that each column, but you know what? I'm going to put column, but I'm also going to put rod is equal to 1/10. So you must shade 3 columns or rods to show 30 hundredths. Okay, then it says, how can I show that 10 times 3 hundredths is 30 hundredths? Well, 3 times 3 hundredths is equal to, or is 30 hundredths. Well, let's find the bigger number, okay? And the bigger number is the 3 hundredths. So we'll have 10 times a number, okay, equals another number. Now remember, when we say we multiply by 10, that means the number's getting bigger. So as a factor, would you want the bigger number or the smaller number here? I hope you said smaller because that's right. Sorry. So we can say that. Or you could write it the same thing and just put 3/10. All right, now it says imagine a model shaded to show 1/1000th. How much would be shaded? Well, right now we don't have one of the cubes, so I have a flat that is 100. Okay, that's 1/100th. Now, let's think about 1/1000th. 1/1000th is 10 times smaller than 100th. So would I actually have to color in a whole square? No, I wouldn't. So I would only shade 1/10 of a single cube to show 1,000. Now, now I think this right here is kind of pushing it. So I have 10 thousandths. So that's kind of pushing it, okay? So if I had to do 1/10 to show 1,000ths, okay? How much smaller is 1/10,000ths compared to 1,000ths? And once again, it's 10 times. So 10 times 10 is 100. So you would only shade 1/100ths of a single cube to show 1/10,000ths. And I'm going to tell you right now, you don't have to know 10,000ths place. We only go to the thousandths place. So they're really pushing it there. All right, guys. That was lesson 1.2, the place value patterns. So now what we're going to do is we are going to do a little worksheet, and it's going to be real simple. It's going to be through a Google slide, and you're just going to follow the Google slide and fill out the information. I will see y'all later.